This is a video lesson about how to solve logarithms, Unit 10, Day 3 for Wednesday. Solving logarithms, we are going to follow reverse order of operations, just like we've solved every other type of function. Addition, subtraction, multiplication, division, both outside numbers. Then exponents, that's where we're going to do the exponential in logarithms, and then whatever's inside parentheses. Remember that exponentials, like 3 to the x, and logarithms, log base 3 of x, are inverse operations. They will undo each other. We're going to start with a very simple one. Example 1, log of 3x plus 7 equals log of 7x minus 5. Now, if these are exactly the same in terms of the logarithms, that means what's inside has to be equal as well. So for this one, we're just going to set what's inside equal, considering that the logarithms are the same. And when I solve this basic algebraic function, I get x equals 3. When you do any of these functions with solving, you have to graph or check these, and one way to do that is by graphing both sides and then doing the gsolve intersect. And I'm going to show that real quick just to review. So what I would do is I would go to the graph app, and I'm going to put the left side in, log of 3x plus 7. So I have log of, in parentheses, 3x plus 7. And then for y2, I'm going to put it in the right side, log of 7x minus 5. Log of 7x minus 5. Now I have the two functions in. Let me turn all these other ones off. Okay. And we're going to draw the two. And I'm going to hit gsolve. And then intersect F5 again. And I see that they meet at x equals 3. I'm looking right here at x equals 3, which is exactly what I got. So I know that this works. One other thing to remember is that logarithms have a domain of x is greater than 0. So you have a logarithm, it can't be 0 and it can't be a negative, it has to be positive. So you can't take the log of a negative. So if I were to plug 3 into either one of these, and this expression would give me a negative, I'd be taking the log of a negative, and I know it doesn't work then. Now x could be negative, but when you plug 3 in for x, if it produces a negative in this expression.
What?
Next question, I have log base 4 of 3x minus 5 equals 3. Now to solve a logarithm, we're going to use the inverse. Log base 4 has an inverse of 4 to the x. So to get rid of log base 4, we're going to do an exponential in base 4 to both sides. This method is called exponentiating. So I have log base 4 of 3x minus 5 equals 3. So I'm going to exponentiate both sides, which means I'm going to take an exponent in base 4 and raise it to that power. Same thing on the right side. In other words, what happens is this becomes the exponent for a base 4, and this 3 becomes the exponent for a base 4. Now, why would I do this? I do this so that these two inverses would cancel out. Exponential base 4, log base 4. They undo each other, and it leaves me with just 3x minus 5. And we used that property in the last unit. 4 to the third equals 64. So now I have an easy equation to solve, and I get 23. Make sure you check your answer. This one does work. Look at one that doesn't work. Number 3, I have the natural log of 18x plus 7 equals the natural log of 10x. And this is like the first example. Both of these are natural logs, so that means I could just set the two expressions equal to one another. And then when I solve, I get x equals 7/8. Now, if I were to plug 7/8 into the right side, natural log of 10 times x, 10 times negative 7/8, which is what I'm saying x is, gives me the natural log of negative 78. I cannot take the logarithm of negative, because the natural log, like every log as a parent function, looks like this. And I want to say that its x value of negative something doesn't work because there are no values back here. So this would not work. This would be an extraneous solution, and the answer would be no solution. Last example. Now we have some stuff happening outside of the logarithm. So we're going to follow order of operations. Addition, subtraction first. I'm going to add 5 to the right side. It gives me 15. Multiply and divide. So we're going to get rid of this 3 by dividing by 3. 15 divided by 3 is 5. So we just isolate it and get rid of the stuff outside. So now I'm ready to take care of the logarithm. How do I take care of a logarithm? I exponentiate. So I'm going to do base 2 raised to that as an exponent. Same thing on the right side, base 2 raised to 5 as an exponent. These two are inverses and undo each other. Exponential base 2 log base 2. It leaves me with just 4x minus 1. It's no longer an exponent, it just comes out and becomes a regular expression. 2 to the 5th is 32. Solve gives me 33/4, and just do a check on the prism to make sure that it's actually works.